Greetings to you people of pre-calculus. Today we discuss 4.3, the remainder and factor theorems. You've seen this in Algebra 2, so this should all be review. We are going to see synthetic division again, and I'll go through that. The remainder theorem says this: if a polynomial p of x is divided by x minus r, then the remainder will be a constant p of r. And p of x equals x minus r times q of x plus p of r. What that means is that if you divide a polynomial by some linear term, linear expression, then the result is some quotient and some remainder. So that is, the polynomial can be expressed as this expression times some quotient plus some remainder. Where q of x is a polynomial, the quotient is a polynomial with degree 1 less than the degree of p of x. That is to say, if f of x is divided by x minus r, then the remainder is f of r. So we are going to practice our division skills, and I am going to do this by long division. I think it's important that you be able to see long division and remember how it works. So to do long division with polynomials, anywhere there is, we've got exponents of 4 and then 2. We're missing a 3. We need to put a 0 in there, just like if I said 1011. I would have to put in a 0 in the hundreds place, same deal. So we've got to put a 0 in for x cubed, but otherwise we've got 4, 3, 2, 1, and 0 degree. This is 2 terms, so we're going to take the first 2 terms. What do I multiply this by to get my first term to be x to the 4th? I multiply it by x to the 3rd. And really you only need to look at the first term here to figure out what goes here. So x times x to the 3rd is x to the 4th, and 3 times x to the 3rd is 3x to the 3rd. You're going to subtract that. X to the 4th minus x to the 4th is 0. 0 minus 3x to the 3rd is negative 3x to the 3rd. Bring down the next term, minus 5x squared, and then figure out what we need to multiply by x to get negative 3x cubed. Well, that's obviously negative 3x squared. So this will be negative 3x cubed minus 9x squared. Just got by multiplying this by this whole expression. Subtract, be careful with your negatives here. Negative 3 minus negative 3 is 0. Negative 5 minus negative 9 is positive 4x squared. Bring down the next term, negative 17x. To get 4x squared, we would need to multiply by 4x. So multiply, you get 4x squared plus 12x. Subtract, 4x squared minus 4x squared is 0. Negative 17 minus 12 is negative 29x. Bring down our last term, which is a negative 12. What do I need to multiply x by to get negative 29x? I need to multiply by negative 29. And that turns this into negative 29x minus, should have done this out first, 9 times 3 is 27. Okay, so that's 87. 29 times 3. Negative 29 minus negative 29 is 0. Negative 12 minus negative 87 is positive 75. So I have a remainder of 75. It's a little bit of second grade math for you. So the result of dividing this whole expression by this linear expression is x cubed minus 3x squared plus 4x minus 29. That's our quotient, with a remainder of 75. So, by doing long division, we get this as the remainder. We would also have gotten the same thing doing synthetic division. I'll do an example of synthetic division to remind you on the back. But regardless, we get a remainder of 75. So according to the remainder theorem, p of r, that is the remainder, equals 75. use the remainder theorem to check the remainder found by long division. So this is the interesting thing. What you get for the remainder is the same thing as you get by plugging in the corresponding root. So if the factor we're talking about here is x plus 3, the root that would correspond to it is negative 3, right? If x minus r is x plus 3, then r is negative 3. So if we plug in negative 3 for x, negative 3 to the fourth minus 5 times negative 3 squared minus 7 times negative 3, negative 3 minus 12. Oh, I'm so tempted to do this myself. You can put it in the calculator though, and you should get 75 if I did everything correctly. That's not a coincidence. The value you get when you plug in that number is the same as the remainder you get if you divide by x minus that number. And that means you can use these to check each other, to check whether something is a root. You know, you can plug it in and check whether it equals 0, to check if it's to check if a factor is if an expression is a factor. You could do the same thing. You can check for the remainder, or you can plug in and find out what it equals, and that will be the same as the remainder. So, by the way, is x plus 3 a factor of x to the fourth minus 5x squared minus 17x minus 12? No, because it had a remainder. It did not divide it evenly. If something is a factor of something else, it means it divides it evenly. 3 is a factor of 15, because if you divide it, you get 5 with no remainder. So, not a factor. So the factor theorem, which is sort of what I just said, the binomial, x minus r, is a factor of the polynomial if and only if p of r equals 0. So this binomial divides the polynomial if and only if plugging in r to the polynomial makes it 0. Use the remainder theorem to find the remainder when you divide this by that. State whether it's a factor of the polynomial and explain. So we are going to test this, and what we do, we could do the division. We could do the long division, or we could do synthetic division and find the remainder. But what we can also do is, using the factor theorem, plugging in 2 for x in each of these places. Will tell us what the remainder is if we divided by x minus 2. So this is 2 times 8 plus 5 times 4 minus 28 minus 8. 16 plus 20 minus 28 minus 8. 36 minus 28 minus 8. 36 minus 28 is 8. Minus 8 is 0. All right. So the remainder of dividing by this is 0. That means this is a factor of the original, and that means this 2, is a root of the original. All of these things are interconnected. So that means yes, f of 2 equals 0. So, trying to think of how to say this. So f of x divided by x minus 2 equals 0. So x minus 2 is a factor of f of x. Here f of x is this. That's the deal. So the remainder, if you divide by the expression x minus r, is the same as the result of plugging r into your polynomial for x. And you can use those two things interchangeably to find factors and roots and zeros, and to check whether something is a factor or check whether the corresponding r is a root. This is a reminder about synthetic division. So here we have an example of using synthetic division to do this division. I'm going to let you work through it, and I'll certainly be happy to talk about it in class as well. Read through it. It should try and give you the whole thing. I'm sorry it's cut off a little here, but nothing important. That's still a 9, that's a 9, an 8, and a 1. I think you can read everything you need to. So they've done the synthetic division. If you have any questions, please ask me. I think it also reviews it in the book. And just as a reminder, when you're setting it up, when you've got your results, what's in this thing here, which we've set apart with a little bar to make this little box, that's the remainder. The next term is the constant, then the linear, or x term, then the quadratic, or x squared term, then the cubic, or x cubed term, and so on and so forth, and the degrees would go up from there. To do this division, so 1, -1, and 4, by taking the numbers out of here. None of the terms were skipped, so I don't need to put in any zeros. And then x minus 2, when does x minus 2 equal 0? When x is 2. So that's what we put in there. Bring the first term straight down, then multiply these. 2 times 1 is 2, and we'll put the result here. We're adding down. -1 plus 2 is 1, 2 times 1 is 2, 4 plus 2 is 6. So our result is x, because that's the x term, plus 1, that's the constant term, with a remainder of 6. And for our purposes right now, you can leave it like that. You could also write it as x plus 1 plus 6 over x minus 2. These are both correct, and I don't much care for the purposes of this chapter which one you use. This saying this is the remainder is totally fine. This, by the way, proves that that's not a factor of this, because when you do the division, you ended up with a remainder other than 0. 1, 1, -17, 15, and in the box goes -5. Please, please, please do pause me, check it, catch up with me, make sure you understand what's going on. I'm going kind of fast, just preserving bandwidth, I guess. Bring the 1 straight down, multiply. Add straight down, multiply. Careful with your negatives. Add straight down, multiply. Add. Okay, here our result is x squared minus 4x plus 3 with no remainder, which means this is a factor of this polynomial. It evenly divides it. Use the remainder theorem. Use the remainder theorem to find the remainder. State whether the binomial is a factor of the polynomial. So we could use synthetic division to find the remainder. Or, by using the remainder theorem, we can also say, well, we can get just the remainder, not worrying about the quotient. If you want the quotient, you've got to do the division. But if you just want the remainder, we can take a shortcut and plug this number in for x and find out what we get. So this is, remember, this is always x minus r. So here r is going to be 3. So we're going to plug in 3 for x. 3 squared plus 2 times 3 minus 15. 9 plus 6 minus 15 equals 0. The remainder is 0. State whether the binomial is a factor of the polynomial. Well, since it divides it with a remainder of 0, yes, x minus 3 is a factor of x squared plus 2x minus 15. And you could double check that. If you factor this, you get x plus 5 times x minus 3. So x minus 3 is one of the factors. This one is a little tricky. This is the kind of, oh, wait, I take that back, sorry. If you were doing synthetic division, this is the kind of one that people would regularly mess up because they would forget to put in a 0 in the x cubed place and a 0 in the x place. But in fact, since we're going to use this, or the remainder theorem to shortcut it, we don't need to get tripped up. So r here is 3. So I'm going to do 3 to the 4th plus 3 to the 2nd plus 2. 3 to the 4th is 81. 3 to the 2nd is 9. Plus 2 is 92. So if plugging in 9 for x gives us 92, that means 92 is the remainder when we divide by this. If that's not 0, it's not a factor. So no, x minus 3 is not a factor of x to the 4th plus x squared plus 2. Determine the binomial factors. So for these, the first thing you have to do is find one factor, because otherwise how are you going to get the rest of them? In order to do that, if it's quadratic, you'd be fine, but this is not a quadratic, and they don't all have a common factor. As I think about it, we could absolutely factor this by grouping. But in the interest of giving you an example, we're actually going to do this the other way. So we want to find one factor. The easiest way to find your first factor is to see if any of them appear on the graph of the function. So I'm graphing x cubed minus 5x squared minus x plus 5. And my calculator's thinking, because it thinks for a while. There we go. Okay. Now, technically we've got all three factors here. Since they're all integers, they're showing them all to us. But let's pretend we didn't. Let's pretend we could only get one of them off of the graph. So here we go. To find one of the factors, you find one of the x-intercepts. Here we have an x-intercept at 1. Sorry, at -1. So that means r is -1. That's one of the roots. So one of the factors is x minus r, that is x plus 1. To determine the other factors, we could do synthetic division. So we're going to say x cubed minus 5x squared minus x plus 5 divided by x plus 1. And I'm going to do the synthetic division. 1, -1, -6, +6, 5, -5, 0. This has to be 0, by the way. If this isn't 0, it implies the first thing you found isn't a factor. And so either you found a number that wasn't a factor, or you did something wrong here. All right, so if you divide, you get a quotient of x squared minus 6x plus 5. That is a quadratic, so you can solve it any of the other ways. This actually factors into x minus 5 times x minus 1. Oops. Setting both of those, well, actually, sorry. They didn't ask for roots, they asked for factors. These are the factors. Don't forget the one you found first off. That's a really common mistake. It's got three roots, so probably 3 factors, and they are x plus 1, x minus 5, x minus 1. Last one, same thing here. We're going to graph it. X to the third minus 6x squared plus 11x minus 6. Aha! Okay. Let's see what's going on here. Ugh. Okay, once again, the calculator is actually giving us all of our roots, but that won't always be true. So let's just take one of these and run with it. So one of the roots is at 1. So we know one of the factors is x minus 1. We can do synthetic division to find the depressed polynomial, that is the one term down. So 1, 1. -5, -5, 6, 6, 0. That breaks this down into x squared minus 5x plus 6. And that can be factored x minus 2, x minus 3. These add up to -5, multiply to +6. Don't forget the one you started with. X minus 1, x minus 2, x minus 3. Now, seriously, even though all 3 roots appeared on the graph, as we go forward and we're doing more of them, there will be some where these roots are not nice integers, and you do need to be able to take this and break it down to the next step. So please do get the practice on this, even though on these problems it wasn't actually necessary. All right, see you later.